with every finger that I'm supposed to? Yes. Because that's actually the most valuable class I took in high school.
There's a typing class? It used to be.
Why is there not? I mean, I feel like it's not cool.
Well, I know that there are some classes that do it for parts of curriculum, but not necessarily the whole like semester or whole year.
Is that the whole?
So when I was in high school, you could take a semester or take a year, and I took a year. Yeah.
I just
Did you just write a bunch of essays?
No, there were lots of different things we had to do, but and they were on typewriters and not computers.
Sick, man.
Yeah. Yeah, but you had to plan when to hit enter at the end or return, whatever it was called at the time. I don't remember.
That was the loudest class, wasn't it?
yeah.
It was. Okay, so we left off yesterday with collision. Collision is when sprites touch or overlap. And obviously, it's important to know when things collide because games and other software test when two things on screen are touching. Oops, I forgot my microphone. I'm recording with no volume. Games and other software tests when two things on screen are touching to decide when to do certain actions, like a game hero collecting coins or running into enemies, or a mouse pointer clicking on an accept or cancel button. So we'll learn the two types of collision today. The first is going to be rectangle collision, and this is the syntax here that you see. Sprite is colliding rectangle, and in the parentheses is your argument, which is the other object that you're checking to see if it's running into, okay? All right, so when we look here, we test collision with simple rectangular boxes. But as you look at these two images, you can see some transparent pixels around the side, which makes it obvious as to why it is not necessarily the most accurate or foolproof method, because it is going to recognize the transparent pixels in the top left, right, bottom corners, okay? So even when it might not look like two sprites are overlapping, if their rectangles are touching, the collision still counts. Let's go ahead and open up Part 3 Wizard. Part 3 Wizard. And if you play or run Part 3 Wizard, you can see this inchworm wizard guy moving around the screen, and then there's a crystal, but nothing is happening. And what we want to happen is for when the wizard catches the crystal, we want there to be a message that says he got it. So if you look in your code under crystal collision comment, there is some space for you to add code. And so we are going to put in an if statement that says if wizard is colliding rect. And the is colliding rect, those three words have to have the underscore in between them. So is colliding rect, and then in the parentheses is crystal. That's the name of the other object. So if the wizard collides with it, then it's going to print got the crystal. And then run it and tell me what happens. Yeah, it just repeats copy got the crystal, and that's because, remember, it's checking every frame to see whether it's happening. So as it passes through, it's doing it. Yeah, so you're getting multiple messages, okay? If we want to make sure he stops colliding with the crystal immediately, we need to move the crystal out of the way when that collision occurs. So just below that if statement, we want to add crystal dot x equals random.randint, and the X should be between 0 and 1,000. And then you can copy that line and paste it and change it to crystal Y 150 through 500. Okay? All right, now when you run it, it's going to, when it touches it, it says got the crystal, but then the crystal should move every time the wizard touches it. Okay, so it is going to keep repeating it every time it touches, but it moves. Does everybody see theirs working? Okay. This wizard thing. The wizard inchworm. Okay. Now that tests when two sprites collide with each other. What if we want to test whether the mouse is colliding with the sprite? Although you see a little arrow, the mouse cursor doesn't represent a sprite. It represents a single XY point at the tip of the cursor. So what information do you think we'll need in order to be able to test whether the mouse is colliding with the sprite? Where what is? Yeah, the tip of the mouse. You have to know where it is, okay? So we have this thing called multiple assignments. And multiple assignment allows us to assign more than one variable with the same operator. So we know that the tip of the mouse has an X and Y coordinate, and we can do X comma Y equals tsapp.getMousePosition. All right, so multiple assignment is used whenever we have multiple values we need to assign to variables at the same time. In particular, this is used with functions that return something called a collection. So a collection is any data type that can store more than one value at the same time. So for now, the important part is that you must know exactly how many values you are assigning in order to use multiple assignment. For getting the mouse position, it will always be a 2 because it returns an X and a Y coordinate. For more than 2 values, you would write multiple assignment the same way, just with more comma-separated variable names on the left-hand side. All right, so now that we know the mouse position, we can check whether it is over a sprite using point collision. So we are going to open part 4. Part 4, feed me. And if you run it, you have a hedgehog that is running in place, and you have an apple that sits still. That's all that happens. So what pieces of information do we need in order to know whether the user clicked on the hedgehog? We'll need to know whether the user clicked and where the mouse was. So a location and if the mouse was clicked. So clicking on a sprite is always composed of those two checks. Did the mouse click? Where was the mouse? So if you scroll down, notice that you have a speed increase section. We first need to assign that variable, or those variables, x comma y equals tsapp dot get mouse position. That's the first thing we are doing. Then we use that x and the y in our if statement, our nested if statement, because we are looking to see if the hedgehog is colliding with the x and y coordinate of the point of the cursor. So if hedgehog dot is colliding point x comma y, and then the nested if is if tsap dot was mouse pressed, then you are incrementing the hedgehog's image animation rate by 5. It's going to make him speed up and run faster. Okay, and if you run that, if you click and click and click, you can see your hedgehog starting to huff and puff because he's running so fast. Okay, now if you look at that, we have 2 if statements there. Do you think it matters which one comes first? Why? It does not matter. You could do either one of these first. Is colliding point or was mouse pressed. Either one is fine, the order, okay? Now we're going to go down here to apple follow, because we are going to make the apple follow the cursor. So we're going to have apple.centerx equals x, apple.centery equals y. That means that it's giving the values in x and y to apple.centerx and apple.centery. That's going to make it follow your mouse. Did he slow down?
Yeah, it's so fast that he's slowing down.
Okay, now everybody should have the mouse following your, the apple following your mouse. All right. Okay. Where am I? Oh, last one. Okay, so if we look at this one more time, just walking through the code, xy equals get the mouse position. That means then that based on that position, you can then give that to center X and center Y of any sprite. In this instance, it's the B. So that means it's going to follow your mouse. Then if flower is colliding with the B, then you're going to make a flower image be flower bloom. Okay? So let me go ahead and hit submit on that section. And we are going to go through together the dog and mouse and the bizarre behavior. So with the dog and mouse, the problem is that the dog loves attention from us. How can we have the dog in the program respond to the affection we give using the mouse cursor? So we'll have the dog change from idle to happy when the cursor is hovering over the dog. The dog should go back to being idle if the cursor moves off of the dog. And the codes we're going to use are get mouse position and is colliding point. So we are going to go to the code. Let's look at this. All right. You do have under assignment, you have your keywords. We are going to go down to the main loop. And we have a while loop that has been started. We need to get mouse underscore X and mouse underscore Y from tsapp.get mouse position Then we need to check if the dog, go ahead and do mouse here. Do mouse here. If dog is colliding point, mouse X and mouse Y, then we will dog.image equals dog happy.png, and remember that the name is case specific. Then we have an else statement, dog.image equals dog idle.png. And then test to see if it works.
Oh, mouse underscore X. Yeah, there's always at least one issue.
Huh? Just so that you can see that it works, is the only reason. No. Okay, now, if you run it, your dog's tail should wag and his tongue should, or his mouth should open and his tongue stick out more when your mouse hovers over it. Did everybody get that to work? Okay. Then go ahead and hit submit and go to the next one, which is bizarre behavior. So for bizarre behavior, again, we're looking at collision. And what do you do when you cross a bee and a pug? So right now, nothing. If you run the thing, you have a bee and a pug, and it should change. We want it to change if they collide, okay? But right now, they just remain the same. So we have to change the image to a pug bee when they collide. And if you look in your project panel, you will see the image pug bee. Okay. Is everybody ready? All right. So we are looking down in collision. And what we need to know is we need to check if the pug is colliding with the bee. So we're going to say if pug.is underscore colliding underscore rect, and we have bee inside the parentheses because that's what we're checking to see if colliding with the pug. Then pug.image is going to be pug.b.png, and we are also going to have the b.image equal pugb.png. And save it and test it. Let them collide with one another. If it works, submit it. Okay? Go ahead and submit that. And then we're going to move on to today's. So as soon as you hit submit, go to today's lesson. And we're going to start with the move with arrow keys demo. So we're going to learn a coding technique that will allow us to move with arrow keys. So moving a graphic around the screen by using directional arrows. Obviously, we have left and right, we have up and down. Sometimes we have a program or a game where we want to be able to use those. So it could be movement games like platformers, visual games like mazes, and anything where a character moves with a speed. Okay, so let's look at how we can control movement with the arrow keys. We can use what we've learned so far to control a character with arrow keys. We can check the is key down state for the arrows to see whether we should move in any given direction. We can use an if, else conditional on each direction. So an if, else on going for the left arrow, another one for the right, another for the up, another for the down. So let's go ahead and look at the code that is associated with this. And we are going to start with just the most basic arrow key movement. Right now, if we run it, we have this character, nothing happens, it's just standing there. However, if we scroll down, we have some space for x-axis, y-axis, and any movement. So we're going to start with the x. If we start with the x, one of the first things that we should do is put in an if statement. If TSApp is key down, so TSApp dot is key down, and then in the parentheses, remember the capital K is a key constant. So TSApp dot K underscore all caps right. And then if it's down, then the character's X speed moves 150. And soon as you get that, check it and see if it works. No, it's the K that makes that K there is what is saying that it is a constant. So it is. Yes, yeah, that capital K is. Oh, no. Well, this does, but the letters don't. Okay, now, if you got that working, then let's go ahead and highlight those two lines, copy and paste. The first thing we do is change the if to an elif, change right to left, and change the X speed to a negative. Then it should go left and right. Then I am going to highlight just character.xSpeed equals whatever. And I'm going to put in an else and then paste character xSpeed, and I change the number to a 0. Because what we want is when you press the right key, you want it to move. When you press the left key, you want it to move. But if you're not pressing a key, you want it to be still. So right, if you click on it, each click should move you just a little bit. Same thing with the left, and then it sits still. Okay? Did everybody get that to work? Raise your hand if you need more time. Okay. Now, we're going to do the same thing on the y-axis. So, the best thing to do, instead of typing that whole thing over, guys, listen. Shh. The best thing to do would be to highlight and copy that entire block of code, paste it under the y-axis, change right to up, left to down, and change the 3 instances of X speed to Y speed, and then reverse the negative sign. So the up gets the negative 150, the down gets the positive 150. And then run it and see if your y-axis character is moving. All right. Now, what would happen if we didn't have the else clauses? Yeah, it wouldn't stop when you release the key. Okay? And why do you think we can't use was key pressed or was key released? Any ideas? So notice that you can actually hold down two keys at one time to make it move. So if you had the was key pressed and released, that would make it hard for the animation to run properly. That's why we use the is key down. Okay? So, improvements that we could make to this little animation would be to make the character face the direction that it's moving, at least on the x-axis, not necessarily up and down, but on the x-axis. Limit the edges. So if it gets to a certain point on the screen, it should stop. And then third would be to animate it while it is moving. So we are going to go back to the code, and we are going to, hang on, I lost my code. There we go. All right. So we have to go back to the x-axis code. What we want to do is at the end of the if statement, before the elif, add another line, and it should be character.flipx equals false, and the F in false should be capitalized. Character.flipx equals false. Then you can copy and paste that, and under the elif, you change false to true. And then go ahead and run it and see what happens. Nothing. You have to run it. Okay, so the character should, the image should flip-flop depending on what arrow you're doing. So I did character.flipx equals false, character.flipx equals true. Next, we want to change the first line in the y-axis section to use and. So what we want to do is check to see if the up key is down, and if the character dot center y is greater than 100. And what is that going to do? Yeah, it's just going to keep the character from flying up off the screen. It's on that up is the only direction that it's changing it. Okay? But it would be easy for us to add that to the other places and modify the number. Not right now. Now you know how to do it. You don't need to do it anywhere else. Now, you have another place, though, down here at the bottom. We've got any movement. Any movement. Yes. So we want an if statement. Oops. Oops. And in our if statement, oh, hang on. Yeah. In our if statement, this is what we want. Actually, I'm going to, hang on, I'm deleting something first. In your if statement, I want you to type if tsapp is key down, tsapp.kwrite. And actually, you could have gotten that copied that from up here too, okay? However, what now you want is to highlight just tsapp through the end. And again, there's no reason to do this. We can do this. We can go find left and do tsapp through the end of the parentheses. And we can say or, and then paste. And then we can do or again and find tsapp through up. And or one more time so that we get down. And then don't forget the colon at the very end. So all you're doing is making sure that you have all four states. I shouldn't say all four states, all four directions that the key down could go. And they're separated by ors. Or. Huh? No. I have the smiley face thing. Oh, you know what else I have? Except for I'd be afraid you couldn't catch. No. I have a lacrosse ball. Yeah, they could hurt some things. All right. So what you're doing now is if one of those things is true, if the key down for right, left, up, or down is true, we are going to put in character.image equals flowernightrunSheet.png, else character.image is flowernightstand.png. What crashed?
I pressed one arrow and Chrome almost crashed. Like whenever you press a button, it's like really laggy to start.
Ooh, it is lagging. There must be something wrong with our network right now. It wasn't this laggy earlier when we did this.
Yeah, it like takes a second for that to load. I don't think it's internet lag, and more it's real. For some reason, this game is really resource intensive.
Yeah, it wasn't this bad earlier. It wasn't that bad earlier. All right. Any questions on this one, getting it to work properly? Okay, so let me tell you what I need for you to do. What time is it? It's 1:30. All right, you guys have about 12 minutes in class. This is what you are going to do. You need to if you finish this part, hit submit, but I want you to keep this window open and open a new tab. You did that? Oh, we'll go back into it. So you have another part, or I shouldn't say part. You have two coding technique practices for move with arrow keys. I am opening both of those that say move with arrow keys. And we'll move the sprite walls to Monday. Okay? We'll move the sprite walls to Monday. But what you can do with having two tabs is you can refer back to your code if you need to. Okay? And make sure you hit submit, please.